Hi, and welcome to the webinar series of Analyze MyWorkpiece Toolpath. My name is Oliver, and I'm the product manager for Analyze MyWorkpiece Toolpath. In this webinar series, you will learn everything that is necessary to know about using Analyze MyWorkpiece Toolpath. This is the first webinar, and in this webinar you will learn everything you need to know about importing data in order to be able to visualize a point cloud, and also how to navigate through the point cloud. So let's get started. First of all, Toolpath can handle multiple import formats, such as MPF part programs and also process data, both coming from a SINUMERIK CNC, but also coming from a SINUMERIK Edge, or you can even import data which is coming from another machine, so a generic CSV import is also supported. And I will guide you through all the supported formats, what you should consider, and how to basically import it. So we start with the very first example, and when you start Toolpath for the first time, you end up here in this user interface, and currently it's quite empty. So we now try to fill this gray space, which will later on visualize the point cloud. We start by importing an MPF file, which is a part program from a CNC. So you hit the file button and import files, and then you guide to the folder where the respective file is located, and here I import this MPF file. I select it, hit the open button, and Toolpath directly imports it. There is no interaction necessary, so when it's an MPF file, Toolpath is able to import it directly. And here we are, we have created our first point cloud. In this case, it's a spiral, and here we are. It's pretty straightforward. Let's close the scene now, and let's go to another type of file. Now we import trace data coming from SINUMERIK Operate Trace, and you can see that it's trace data based on this XML format. So let's import this one. And now you see a difference between importing an MPF file and trace data. When you import trace data, you need to execute a mapping. Toolpath needs to know which signal is for the X, Y, and Z direction in the room. And as you can see here, we have, it's unfortunately in German, the description, but it says basically the first three values is the actual position values of the second encoder. And those three lines here are indicating the commanded position values. And normally these are X, Y, Z from top to the bottom. If we want to be sure, we can hover with the mouse over here, and then we see the BTSS address. We see at the end the array, it's U11, then U12, U13, so that means that's XYZ. So that also means now Toolpath tries to find the correct mapping. Normally you just simply can import it when it's coming from a SINUMERIK, but just to make sure what happens here. So first of all, the signal that is checked is a signal that gets imported into Toolpath, and the least minimum signals that Toolpath requires is XYZ, and the symbol name needs to be position. We will come to the symbol name later, but for now, just you can see there are other options. So to get the first import of process data, you need the symbol name position for each signal, and then you need to map XYZ, and it should be correct. If you mix it up, then you will end up with a point cloud that probably doesn't make any sense. So let's choose the proposed mapping, and now we hit the import button. And now we see here on the bottom right, Toolpath is loading the data. And after a couple of seconds, the point cloud is being generated. So here we are. This is now our file. And yeah, I can navigate through it. We have the data here, and you can see all the points and the process data. So this import was also successful. So let's close the session. And let me now show you another way of importing data. So therefore I make my Explorer visible. So what you can also do is import data by simply dragging and dropping it into the Toolpath window. So I take the file here, put it into this gray area of Toolpath, and then I release it like that. And once it's passed, Toolpath shows me the import dialog. And here I see all the available signals, and as you can see, it's quite a few compared to the example we just saw before. That's due to the fact that the data was recorded with SINUMERIK Edge using Analyze MyWorkpiece capture. And with capture we can record up to 100 variables. And let me now show you one example how you can visualize two position point clouds into one scene. So first of all, Toolpath took the DES-POS values 1 to 3 from the axis x1, y1, c1 and mapped it accordingly. So that stands for commanded axis position. And now we take the encoder values, which can be found like here. Let's take them from the second encoder, so encoder 2 position. And what we now do is we simply map it as a symbol name position 2. Again with XYZ, here also X1, Y1, C1. And now we have two positions that will result in two different models in the same scene. So let's import it. So now the import just finished. So this is our point cloud. It's now a different workpiece. And what we can recognize here is that there are two lines, two yellow lines, and each line here indicates a so-called model. So we have one scene, and each scene represents an area where you can import point clouds. And each line here within a scene represents a model. And we now can see that we have actually two models imported. And as you remember, during the import wizard, we selected a position 1 and a position 2 mapping. And this is now considered here. If we collapse a little bit this area, then we see, okay, on top is the commanded axis position and on the bottom is the encoder position. Let's just rename this so that we can quickly identify it, because this name is quite long. So we say commanded POS, and here we say encoder POS. So it's now a smaller name. We can decrease this now a little bit. And the question is now, can we also see this in the point cloud? So I now use my mouse wheel to zoom into this area. And if I right click and stay on right click, I'm able to move in a linear way through the point cloud. And if I click and hold the left mouse button, we are able to rotate through the scene. Okay, so right button is move and the left button is rotation. And if we now zoom very, very closely, I just use this button to change the orientation a little bit. So we now look on the model from the side. And if I zoom very, very closely, we now see two different lines here. And the question is now, which one is the commanded position values and which one is referring to the encoder position. In order to see it, first of all, we can use this I button and make, as an example, the encoder position invisible, and then we see only one line here, so that's the commanded position values. And we can do it also vice versa. But an even more efficient way is changing the coloring. So if I now click on this icon, I have the possibility to adapt the scene and customize it to my needs. We can select the color for non-selected points and selected points. What that means we will see in a few minutes. We can change the line color and additional colors when it comes to the measurement tool. What the measurement tool does I will also show in another webinar. For now, let's just change the color of the points. So I would like the encoder positions to be red dotted and the line I want to be yellow. And now we can see the difference here between those two lines. And now we directly understand, okay, the blue line with the green buttons, or with the green dots, this is my line for the commanded position values, and the yellow one for the encoder position. So we now just imported a model with commanded position values and encoder position values into one scene. And I will now show you a different way how you can achieve exactly the same goal. So first of all, let's close the scene again. And I will now import a SINUMERIK trace file, and we select this one. Yeah, let's take the smaller one. We select this one, so I do it the same way. I put it on here onto this gray area. And now comes the mapping, and we have this is the actual value set, and here we have the commanded values. But unfortunately, a current restriction with Toolpath is that you can, when you import trace data coming from Operate Trace, you only have one position. You cannot select position 1, position 2. But that's not such a big deal, so there's a workaround. First of all, let's start importing the commanded values. We select position and map it to X, Y, and Z. We import it. So the points now have been imported. And now into this scene we import another model. We have two ways of doing so. We can either click here File and then Import Files to Active Scene, and whatever gets imported will be imported into this scene. And there is a second option, which I prefer. I go to my Explorer again, select the file, click it, hold it, move it into the Toolpath scene. And now what is very important, you need to release the file in this area in the scene or on the points, wherever you would like to. You should not release it in this area. If you release it here, then the file gets imported in a new scene. We will do this in the next step, and you have also benefits doing that. But for now, let's import the same file we just imported into the actual scene. So let's release the mouse button and we see the same import dialog again. And now let's deselect those three signals and select the one on top. So the actual values, map it to X, Y, Z. And if I now click import, the points get imported into the scene. So now again we have two lines here. They have the same name because the points come from the same file. So to know what I did there, at a later point of time I now can say, okay, this is commanded and this is actual or encoder, whatever you would like to. And we can change the coloring of the actual again. I say I would like this time the points to be purple and the line I would like to be green. And if we now zoom very closely again, like very closely, we see two different lines here. If I would like to increase the size of the points here, I click this button on the top right. We will come to that section later, but for now I think it makes sense. And let's just give it a few clicks, then the point size is increasing. And here we now see two different points. So this is actual and the commanded position values. So I just showed you a different way how you can import multiple models into the same scene. Okay, so much for this example. Let's close the scene again and let's continue with a different example. Another supported file type of Analyze MyWorkpiece Toolpath are STL files. So the output that basically comes from every CAD system. And let's simply by using drag and drop import it. So this is our STL file. It's quite a simple geometry, but we can import that as well. And why should we do that? Well, what we now can do is we take as an example the MPF file and put it into the same scene which refers to this STL file. And now we see the point cloud mapped against the geometry, and that's actually quite helpful because sometimes maybe the point cloud alone doesn't help you to understand where in the workpiece you are. So by using this, placing several models into one scene, again, we can put a point cloud onto a geometry. And additionally, if we also now take an Operate Trace data file as an example, mapped with the XYZ coordinates just for now, this one also becomes visible, and then you can perform all the analysis which you will learn in later webinars. So let's import an MPF file again. We put it here into this gray area and give Toolpath a few seconds of time. So now we see the MPF file. So this is a mold and die part, and let's just import now the process data for it. And now I'm doing something differently. I do not paste the file here into this black area. I put it here into this blue area. And by doing so, the file gets imported. So I see the file import dialog again. And this only has 3 values, so it's mapped accordingly. And let's import it. And now we see both files next to each other. And if we just align them like that with this camera icon and click here. And now I click here this chain symbol, so it looks like a chain, and it synchronizes 2 windows. So now both windows are synchronized. And if I now start to rotate or move in one of the windows, or even zoom, both actions are always synchronized. So during my analysis, if I would like to find out, okay, what is exactly happening in this area on my real world example from the data coming from the machine, you can directly compare it. So you could have also achieved the same thing while clicking File and Import Files. Then also the files will be imported to a new scene. So if I would like to, I can now, let's say import the file once more. We see here in the middle or on the right. And now we see 3 times the same thing. And if desired, we can now even synchronize 3 different scenes with each other. So it is totally up to your respective use case. So let me show you something different now. Let's import the data again from the spiral, and now we just take the process data, and here we see apologies again, unfortunately it's in German, but these first 3 lines here that are selected showing the actual values, so in XYZ direction, and here we see the tool orientation using the BTSS variable VC-tool-O, and we can take this and import it, but now we should not take the symbol name position, but we should take orientation. So Toolpath offers a few standard symbol names that will come along during your analysis journey, and one of them is orientation, and orientation always expects also XYZ direction. If you just import 2, it does not work, so Toolpath grays the import button out. You need to import 3, and let's just import it. And now we see the spiral again, and here on the right there is this button saying change orientation vector length. So if we click it and the scene contains orientation vector information, then we can visualize now this vectorial data. This also works for part programs if they contain orientation information. So if we take the MPF file again, where we do not have to map anything because the orientation information is implicitly given by the program, we click here, then we also see the commanded tool orientation. There is also another type of import that can be executed. Let's import another file again. So this is again coming from Capture. We start with position here. We just get rid of position 2 for now. I'm not interested in it. But what I now would like to see is the torque. So if I'm interested in the torque, let's say of the 3 motors of XYZ, X1, Y1, C1, I can select the torque field here, and we could even import the spindle torque. And to be able to understand later on which one is which, let's just for now rename to torque spindle. So you can click into this field, you can remove the symbol name, and you can give it a new one. And what we now do is the following thing. The torque signals here, we will import them as a vector with 3 components. And this one here we will import as a scalar. So if you collapse this one here, you can also define a signal to be a scalar data type. And what you can do with it, I will show you in a minute. So let's just import the data now. So here we are, this is our model. And we now have here in this section, and I will in another webinar go deeper into this section, but just for now, we have here now torque and torque spindle. So I can now execute a color coding of the spindle torque. And if I move the boundaries a little bit, we can see here a colored path. Red areas now indicate areas where the torque is around 2 Newton meters, and the blue areas it's 0 Newton meters or lower. So we can use the scalar field import for dimensional, we call it 4D coloring. So you add a fourth dimension to your data. And let's just clear this for now. And the second option we now have is here we see the torque. And this is the torque of the motors of X1, Y1, C1. And we now see a color coding for the magnitude of the torque vector. You can even visualize the single components, but I will show you this in another webinar. Just for now, you should understand that there is a torque vector. And we can even click this button here, indicating custom vector, change the custom vector length. So the torque signal was recognized as a custom vector. And that means if we click this button here, we can now also visualize the torque as a vectorial size. Okay, so much for that. Now let's come to the very last example. So far we imported MPF files. We imported XML files coming from SINUMERIK Operate Trace or CSV files, that's also possible. And we imported zip files coming from Analyze MyWorkpiece Capture or Capture for Analysis that have been recorded with SINUMERIK Edge. And the last type of files we support are CSV files. So I've prepared here a CSV file. It's called test file CSV. And I created the first line with 4 columns, a time column, first, second and third column. And then I just entered some arbitrary numbers. And if we now import this in the same way as we did it now before, Toolpath shows the mapping window, and since Toolpath doesn't know this kind of CSV file, it doesn't propose anything. No, so we now have to execute the mapping. So we say the time column is a symbol named time. It's a scalar type, so it doesn't have any room orientation or direction. And then we have position, where we say first column is X, Y, and Z. And now we can import it. And basically what you now see is just 3 dots, because this file just contained 3 data lines. But what I wanted to present is that Toolpath also supports importing data from any data source. And the only thing you need to do is at least map the 3 room directions. You also could see that I mapped a time signal. That's not necessary. You have some more features if you add a time signal to your data set, but it's not necessary. And we will come to that in another webinar. So for now I would close this, and this was the first webinar about Analyze MyWorkpiece Toolpath and how you can basically navigate through the scene and how you can import data from various data sources such as SINUMERIK Operate Trace, Analyze MyWorkpiece Capture, Capture for Analysis with SINUMERIK Edge, and MPF files, and also, last but not least, generic data sources using CSV files. Thank you very much for watching, and I hope to see you in the next webinar about Analyze MyWorkpiece Toolpath.